Hello everyone, my name is Siddhi Madne and I am engineering student of Electronics and Telecommunication branch pursuing from Shivnagar Vidyaprasarak Mandal College of Engineering Malegaon. I would like to thank EMERTXE Information Technology Private Limited for giving us opportunity on Internet of Things internship and making a project on home automation. This project is made by me and my friend Shreyesh Patil. Firstly, the content that I have used in this project are Introduction, Objective, Embedded System, Arduino IDE, PixSimLab, Garden Light, Temperature Control, Serial Tank, Simulation, and then conclusion. Let's see the introduction. IoT home automation is the ability to control domestic appliances by electronically controlled internet connected systems. IoT devices are basically smart devices which have support for internet connectivity and are able to interact with the user directly across the network as per their need. IoT based home automation system offers a lot of flexibility over the wire system. The benefit of having this system are ease of use, remote location, accessibility, energy saving through wireless network connectivity, easy fault detection and triggering, and easy mobility. In our project, we will develop an IoT-based home automation solution which has garden light, temperature control system, and serial tank control. What is an Internet of Things? Internet of Things is the networking of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. The most important feature of IoT on which it works are sensing, analyzing, and action. It enables complete system for controlling and monitoring multiple physical objects through a network. There are many advantages of Internet of Things. Here is the IoT architecture in which cloud gateway, control application, model, machine learning, web application, mobile application. Let's see how IoT does it work. The working of IoT is different for different IoT ecosystem. The key concept of their working are sensors, platform, applications, and devices. The sensor collect data, platforms store it, applications analyze it, and device perform action based on data. IoT connect devices through network and transfer the most valuable data with application to devices. What is an embedded system? Any combination of hardware and software which is intended to do specific tasks can be called an embedded system. Has three parts of software, firmware, and hardware, unlike computer. Embedded system perform few specific limited tasks. Embedded devices have peripherals such as serial communication interface, synchronous serial communication interface, universal serial bus, multimedia cards, etc. These embedded systems provide output in particular defined time interval. Let's see the project requirement component. Uh, First, Arduino. The Arduino UNO is an open source microcontroller board based on the 80 mega 32.8p microcontroller. It has 14 digital input output pins, 6 analog pins, and 60 megahertz quartz crystal. Then USB connection and power jack. It supports C and C++ programming language using special rule of code structuring. Here is the Arduino IDE desktop. Then PixSimLab. PixSimLab is a real-time emulator of development board for microcontroller. It support use with PickKit programmer and MPLab integration for programming the board microcontrollers. PixSimLab supports several devices, for example LED and push buttons for simulation, and add modules like Ethernet or graphic display for internet connection or touchscreen LCDs. Is the diagram of PixSimLab. Then garden light control. The controlling of garden light is based on LDR sensor. The description of this control is to read the LDR sensor value based on the input from LDR. Vary the brightness of the LED. It resembles controlling garden light based on the availability of sunlight. Then temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor and a cooler. It resembles the temperature control system at home. Read the temperature for LM35 sensor and display it on NCD. Control the temperature system by turning on off the heater and cooler through the Blink IoT mobile app. Here is the diagram of temperature control system. Here is the Blink IoT app, then Arduino ID, CLCD and temperature system. Serial tank control. The serial remote tank is a tank simulator controlled by a serial communication protocol. The tank has several sensors and actuators that can be read and controlled using the communication protocol. Let's see the conclusion. Using Bing IoT application and PixSimLab simulator simulated home automation where LED temperature system, serial tank resembles light heater, cooler and water tank in real time. CLCD act like a dashboard used for displaying the event wedge from the Blink IoT app like button wedge used to control heater, cooler, inlet wall, outlet wall. A gauge which display the temperature and volume of the water. Let's see the simulation. Before see the simulation, I show the project codes. Here is the code of home automation Blink control INO. Here is LDR, CPE, then LDR.h is main header file, then serial tank .cpp, serial tank .h, this temperature system.cpp, and then temperature system.h. Simulation part will explain Shreyash Patil. Thank you.
Next, I would like to explain the project with an experiment. So let's get started. I would like to open the Pixim Lab. So this is Pixim Lab. Now I would load the hex file. I'm loading the hex file. I select the home automation temp file 5 and open it. Bootloader open. So the file is open and we are ready to go. This is the CLCD display. Here T is equals to 27.37. This is the temperature and this is the LDR sensor. This is the LDR sensor. LDR stands for light dependent resistor. This is the sensor which is used to detect the light. When we off the LDR sensor, when we scroll it down, the light is on. When we scroll it up, the light is on, and when we scroll down, the light is off. See, means during daytime the garden light should be off, and during night time the garden light should be on. That's why we use LDR sensors. These sensors are active and interlinked with the light very much, so that they can detect the day and night. So the differences can between the day and night can be identified with this LDR sensor, so that turning on and off will be easy by using this LDR sensor. So I am now connecting my mobile with the Blink IoT app. This Blink IoT app has two tabs. Tab 1 here as the cooling system, temperature control system. Now let's see. If I on the heater, then the temperature in the CLCD display automatically goes up. Initially the temperature is at 27 point something. Now the temperature is at 35.19. Now see the notification is okay. Temperature is above 35 degrees. Turning off the heater. Here we didn't get involved. Automatically the sensor detected the temperature is going above 35 degrees. So the heater will be turned off and cooler will be turned on automatically. See, the cooler will be turned on. Coming to the next, serial remote tank. This tank contains sensors at the top of the tank and end of the tank. This tank has both inlet valves and outlet valves. There will be two buttons for inlet valve and outlet valve, and the total capacity of the tank is 3000. Let us assume. Okay. If I on the outlet valve, then the water inside the tank will be going out. Then automatically, if that tank capacity is less than 2000, then the inlet valve will be opened, on. See, here after crossing the 2000, the inlet valve is automatically on, turned on, and the water inside the tank will be filled. See, when the water in the tank reach the LDR sensor, the outlet valve will be turned on, and the inlet valve will be turned off. This is the main intentions behind this simulation tank. Yes. Thank you. This is my project, home automation project. I'm very much thankful for EMERTXE for giving me this opportunity. Thank you.